Hey folks, I'm just gonna give everyone a moment to log in and then we will start. Hey everyone, good morning or good afternoon, wherever you may be joining us today. Welcome to today's webinar co-hosted by the New York Oracle Users Group and Oracle Partner Viscosity North America. We've got a great presenter today, Stacey, Director of Database Product Management at Oracle, presenting for us an introduction to Oracle Database 23 AI Vector Database. So I'm very excited and expecting to see some great questions from the audience. This is a live webinar, so feel free to submit questions to the Q&A field, and our speaker will get to your questions as soon as they can. And yes, this is recorded, and you can rewatch this webinar and download slides at orapub.com. If you're not familiar with viscosity and NYOUG, hello, my name is Alina Skripinets, and I'm the marketing manager for viscosity here. And viscosity is a full Oracle stack consulting firm, but I will tell you more about it. And now, first, we've got today Coleman Levitas, the VP of NYOUG, who is going to tell us a little about NYOUG, and then I'll quickly introduce you to viscosity.
Thank you, Alina, for the kind introduction. Do you have the slides on the screen?
Yeah.
Okay. I don't see them yet, but I'll just go into. So the New York Oracle Users Group was formed for almost 40 years ago for presenting information about different aspects of the Oracle framework to users such as yourself. You can reach us on nyoug.org or with Twitter, or was Twitter, now X, and of course Facebook and LinkedIn. And just if you want to reach me, it's cleveter@ieee.org. And I want to thank Viscosity for co-hosting these series of webinars since 2020. And I want to thank Stacey for contributing today as a for the webinar. Thank you, Alina.
Thank you. Do you see now the slides or no?
No, we're past that point. That's fine. If you want to go into the viscosity slides, it's not, we can't see it on the screen, so just present what you can present, and then we'll go to Sean.
Oh my gosh, 1 second. Share. Okay. Now?
Yes,
you see?
perfectly.
Finally, okay. So Viscosity is a full Oracle stack consulting firm with core expertise in Oracle database, including RAC, Oracle Apex, near zero downtime migrations. We also do performance tuning and high availability. And we also have decades of experience with infrastructure, including engineered systems. So Viscosity is built on these three main pillars: data, apps, and infrastructure. Down the left side, you can see that we offer a variety of services for all pillars. Services included within our proven solutions and professional services include assessment, health checks, proof of concepts, and training. If any of these pillars speaks to you and your organizations, please let me know. I'd love to get you in touch with some folks from our team and see how we can help you. Or if you need a training, you can head over to orapub.com and search for the topic you are interested in. There are some of the 30+ books written by our consultants and executive management. Hopefully, you currently own some of these. Our most recent books are on Oracle performance tuning, upgrading Oracle databases, or Oracle on Docker. The folks you see on the screen here represent some of our consultants who are recognized by Oracle as thought leaders in the Oracle database and development community. They present all over the world on Oracle topics and write blogs, books, and case studies to continue helping the Oracle users community and Oracle customers. We have several people on our team who used to work in Oracle license management, and one of the big things we help customers with is making sure they pay for what they need and that they're getting the best rates possible. We also have a huge Oracle Apex practice that takes something you already have built into your investment to create customized apps for your actual day-to-day needs. Now about our OraPub platform. As of January the 1st, 2022, it is powered by Viscosity and founded by former Oracle employee and current Oracle ACE director, Craig Schellhammer. And Craig developed like 1 year ago Oracle Performance AI Assistant, Shane AI, that you can test out on our OraPub platform. Free and paid OraPub members can currently take advantage of this Shane AI assistant, and the higher tier you have, the more possibilities and questions you can ask Shane AI. He's also called Surfer Shane. So OraPub is your one-stop shop to see recordings and slide decks of all of our free webinars like today's. You can sign up for a free membership to access this content, and you can also pay for another tier for access to more in-depth live virtual classes and more personalized experiences. And receive the information you need to shine at your workplace and to continue grow professionally. So here at our page, you can check out our upcoming events, and there are a few more free webinars coming this month: low-code AI and future of app creation with Oracle Apex next week, and Oracle database patching the right way out of place, and one how-to webinars for OraPub paid members. And yeah, you can follow us online. And with that, I'm going to turn over back to Coleman, who is going to introduce us to the speaker today.
Thank you for that, Alina. I just wanted to let all the participants here know today that next week we have Mark Suits will be talking about Apex AI, and that'll be on August 20th. And on August 27th, we have Viscosity's Gary Gordhammer talking, giving a webinar again on that topic. And want to thank again Viscosity for co-hosting these series of webinars since I think May of 2020, and we're continuing move forward with this. And again, thanks Sean Stacey for presenting today. Sean, it's all yours.
Thanks, Coleman, and thank you, Alina. Let me get my screen share working. Do you see my screen okay?
Yes, fine. I just wanted to add that if anybody has any questions, please put them into the Q&A, and we'll periodically look at them and respond to the questions.
Oh, yeah, thank you so much. And yeah, thank you also for giving me an opportunity to speak to you all today. I really appreciate it, Coleman. And in terms of the other sessions, I'm pretty honored to be able to speak after Paul Parkinson and then Mark and then Gary, all really knowledgeable people. And there is a piece, Paul did reach out to me and he mentioned that he had introduced some of the topics I'll be talking about today, but he didn't go into a lot of detail. So hopefully you will learn something completely new today. I am going to show you some live demonstrations, and my plan is to not bore you with PowerPoint slides, but to show you some live demonstrations. And also, I will also throw out there that prior to the pandemic, I used to love heading to this live event, and I really do miss it. So I'm glad you can all make it in a virtual format, and hopefully I'll get to see you perhaps at Cloud World. If any of you are going to be at Cloud World, definitely do look me up. I recognized a couple of names there, and I would love to see you all in the demo grounds. And Cloud World will be in less than a month in Las Vegas this year. So let's move on with my presentation. And the first thing I want to talk about is the fact that I will be focusing today on Oracle's AI capabilities that are available to you in the Oracle database, specifically around our vector database. But I'll also be covering a little bit around our Select AI and about our applications. But I just want to point out that the Oracle Cloud Infrastructure is a legitimate platform for running AI workloads, right? We have a slew of GPUs that are available for your use, whether they're NVIDIA A100s, H100s, Grace Blackwells, you name it. We have high performance computing systems to support those workloads, right? The GPUs are only performing the actual processing. There's actual volumes of data that needs to be accessed, and that's where our high performance computing systems come into play. And then we also have a very rich framework of networking, and we have RDMA networking. If you're not familiar with it, it's memory to memory networking. And this is what we're sharing with some of our larger customers to build or deploy their superclusters. I heard that, or I saw it published, that NVIDIA is running supercluster with 32,000 GPUs in one of our cloud data centers. And that's possible by using our RDMA networking to interconnect these systems with all these GPUs on board. And we have some big names that are using our OCI infrastructure for running their LLM training and training their models. And if you're interested in finding out some of those names, Larry Ellison talks about them during our earnings announcements. I recall him mentioning XAI, OpenAI, Palantir, NVIDIA, and the list goes on. With respect to the scope of what they're using and how they're using it, I would once again tell you to listen to Larry's latest earnings announcements, or even attend Cloud World, and you'll get an update on where we're at. But the actual infrastructure and running those workloads is one aspect. The other piece is actually supporting the data platform for running those workloads, and that's where our database comes into play. So I'm going to be focusing on these three topics today: the Gen AI, the Oracle Database AI Vector Search, and our autonomous database Select AI capabilities. Now, for customers who are using MySQL, we have HeatWave, and we've added vector store and Gen AI capabilities to HeatWave. We have machine learning built into our Oracle database. We have data labeling for helping share relational information with large language models, and a number of other services that are or a platform for deploying those workloads. Now, when it comes to services, Oracle has a number of services that are available for you to consume, from digital assistants to speech assistants to language, which is multilingual support, vision for image recognition, document understanding for reading through documents and generating AI information from that. But we have a number of Gen AI agents that are also available to you, as well as we have the OCI Gen AI service, which is based upon Cohere. Now, for customers who are not looking at building their own AI services, but looking at extending their applications to leverage those services, we're also building support for our various AI capabilities into our application suite. So our consumers of our HCM, our CRM, I believe our ERP, Fusion applications have access to our digital assistants, have access to speech and other chatbots. So do be aware of that. We also have a very broad community of partners and ISVs, Viscosity being one of them, who are working with our customers to support them with these AI use cases. So If any of you have ever attended any of my sessions, and I do recognize some of you in the attendee list, you'll be familiar with this slide. I always have to put this one up. This is taken from my Oracle support note 742060, and it's really important if you're looking at installing the Oracle database anywhere today, and you're not sure about what version of the database is available for that particular platform, or if you're interested in determining when you need to transition off of a platform, this is the place to look. You'll notice that 19C and 23AI are both listed as long-term supported release. 19C will be available through April 30th of 2026 with Premier support. And after that, for the following year, you will need extended support. But the point is, we're not forcing you to make that transition from 19C to 23AI anytime soon. We've given you a fairly good runway in which to transition your workload, so to speak, to make that move. But the point I also want to make is that 23AI is our latest long-term supported release, and it will be around on through the 2030s. So if you're looking for understanding what version of the database you should be moving to for your mission critical production workloads, don't hesitate on making that transition to 23AI. We intend to support it for a long time. So one of the questions I often get is, okay, we had heard about 23C. What's the difference between 23C and 23AI? And really, the main point I want to make is that 23C was always our initial or our intended name that we were going to use this version of the database. And in fact, we rolled out 23.2 in April 2023 as part of our database free edition. And then in September of 2023, we released 23C in the cloud. So as part of, we updated our Oracle database free to use that latest version. And then we also released 23C support in our OCI cloud. Now, in late 2022, the decision was made to incorporate AI capabilities into our database, and our executive management viewed the introduction of AI capabilities within the Oracle database as being significant enough, with the idea being that this was going to be around through the 2030s. We had to ensure that this would be available in our next long-term supported release, and thus the decision was made to slow down the release of 23 to include AI capabilities. And the decision was also made at that point that we would rename 23 to be 23AI. And at that point, in October of last year, we introduced the base DB, the Exadata Cloud Service, and Cloud at Customer. And in January of this year, or actually, January of this year, we included support for Autonomous Database Always Free. And we've continued to add functionality, as you can see, in May of this year. Most recently, in June, we introduced support for our engineered systems on premises. And as we speak, we're also rolling out support for Autonomous Database Paid, which was prior to that, always free. Now, I'll also point out that the current version of 23AI, the latest version out there right now, is 23.5. And if you're using Oracle Database Free or Oracle Database Developer Free, it may not be obvious, but you may want to check and see when it was most recently updated on the website to do the download. And you should see there if it's 23.5. If it was released later than May of this year, then it will be the 23.5 edition. Now, one thing I do want to point out, and I'll jump to that slide and come back, just to kind of summarize that conversation. Sorry, let's see if I can get my screen to appear. It's not doing it, is it? Yes, there we go. So I do want to point out the fact that we rolled out that functionality in 23C. The bulk of what we see on this slide was released as part of 23C, right? AI vector search is really only the new thing we've added with 23AI, but it is significant. But the reason I'm pointing this out is that if you have a workload today that you're interested in running, or perhaps you're interested in one of our features such as JSON relational duality or real-time SQL plan management, or using our new property graph capabilities that we've enhanced, do not hesitate. 23C and 23AI are production ready for any of those workloads. And we added over 300 new features in 23C alone before we added this additional AI support. So let me go back a slide, and I want to talk about this one. And this is a screenshot from Cloud World of last year. And this is where Juan Loaiza, one of our two executive vice presidents for the database development team, took the stage and talked about what we're doing on the front of AI as it relates to the Oracle database. So the first thing that Juan talked about is support for generative AI and retrieval augmented generation. And the way we're doing this is, first of all, with generative AI, we're supporting generative AI through the Oracle database itself through a feature called Select AI, which as of now, right now, is available as an autonomous database feature. It's completely free to use. There's no additional cost to use this service, but this allows you to use natural language to converse with your Oracle database. And take note, it's with your Oracle database that generative AI works. Now, retrieval augmented generation is all about taking information from your database and using that to help enrich the information that you're retrieving from a large language model. So in essence, what you're doing is training or refreshing or updating the large language model with information that's specific to your business. And we provide this not only through supporting our OCI Gen AI service, if you wish to run that large language model within your own guardrails and within your own private tenancy, or we can allow you to work with external large language models if you wish to work with OpenAI or any other large language model that's out there. The other area that we're innovating with 23AI is with respect to generating applications and using Gen AI to build and deploy those applications. And I'll talk a little bit about that later. But then the big one that we've introduced is our vector database. And that's really where I'm going to focus my attention for the majority of today, including some live demos. So I'm not planning to present too much. I really want to focus on some live live demonstrations. But I also want to make it clear for those of you that may not be aware, when you think of AI in the Oracle database, there's three facets, or there's three areas in which you could categorize AI support within the Oracle database. And the first area is with our machine learning engine and our AI machine learning models. So these models have been available in the Oracle database for well and truly over 20 years. We have over 30 of these algorithms that are available for you to use. They're there. There's no additional installation required to use them. There's no additional cost to use them. And they're really what you would consider using when you wish to apply AI and machine learning to your business data. So if you've got relational information stored in your database and you want to apply predictive analysis or fraud detection, or you want to classify information, this is the set of products you would look at using. Now, if you're using our autonomous database, we have a series of notebooks that are based on Apache Zeppelin with pre-built patterns that you can take those patterns and fill in the blanks to use these different machine learning algorithms that are there. We have APIs to extend that to work with Python, R, SQL, you name it. We have visualization support and everything else that goes with it. And we also support other notebooks as well. Jupyter notebooks work just fine with our tools as well for this front. Now, the other area that I mentioned is our SQL generation with Select AI. And this is where we're providing a mechanism to use natural language to converse with your database. And in this case, we're asking, this is a good example where we're asking a question that's definitely not SQL in nature. And we're querying or inquiring about movies that are in our database. And we're able to do that using this command Select AI, and it's able to return our results. Now, one aspect of using natural language and using Gen AI to query your database is the possibility of hallucinations, right? And hallucinations, to put it simply, is false information or false positives. So we understand that for an enterprise solution or business solution, this is something that you have almost zero tolerance for, right? That there are cases or instances where hallucination may be a good thing, but in the case of a business workload, it's definitely undesirable. So the approach that we take to help you combat or feel comfortable with what's being generated, we give you a parameter here. You can see we type select AI space show SQL, and it shows you the SQL it will have generated to perform this query. And if you're like me, you'll simply cut and paste that SQL and use it wherever you want to use it. Now, to dive into this a little bit deeper, if you think about it, we're asking what are the top 10 streamed movies that were released in 2010? First of all, what are movies? Where and where are we getting this information from, right? And what is 2010? This information is in our database, and we need to instruct or communicate with the large language model, train the large language model to understand our database. So the way we do this is we provide a context where we provide information about or metadata about our database, and that's then passed on to a large language model to be able to generate SQL based on that statement that is then pointed or directed towards our own database. Now, the large language models we support right now are Cohere, OpenAI, and Llama 3. Well, last time I saw Llama 3 was imminent, and that was about a month ago. I haven't looked at it recently, but prior to that, it was Llama 2. So I believe Llama 3 support should be there now. But the other piece you do, and I'll show you some code samples on how you would set this up, is you need to let the large language model understand what your tables are. You need to provide it with your token to authenticate to the large language model. And then you then connect to it. You set your profile to point to that token authentication and go to town at that point. So I'll show you a quick demo in a moment on how that works. And now the other one is with respect to Apex for application development and all the generative AI stuff we've rolled out on that front. I'm not going to steal any of Mark's thunder. I believe Mark is going to be talking this time next week to talk to you about what we're doing with Apex. What I can tell you is we have a chatbot. We have the ability to generate reports, to help customize your canvases, to write your business workflow, all through generative AI. So we have some very powerful capabilities, and I would strongly suggest you attend that session to see some of the cool stuff that we're doing with Oracle Apex. Now, the big one I want to focus on today, though, is our AI vector search. And for those of you who are not familiar with what vectors are, let me drill into this one for you. So a vector, think of vector from a computer science standpoint. A vector is really an array, and it's an array of numbers that are typically int 8, float 32, float 64. They're defined by an embedding model, and these vectors contain these array of numbers or dimensions, and these vectors of these dimensions contain a mapping to an object, whether that object is a photo, a PDF document, or a Word document, or a text file, or a video. A vector is generated by running a transformer using an embedding model to scan whatever that object is and to generate this vector to provide information or metadata about that object that we've scanned. So in this example, and you've probably seen this one, but I think it does such a great job of simplifying the concepts. In this example, we have a photograph of a house, and we can see the vector for it there. It's got 4 dimensions. The first dimension tells us the type of roof, the next one, the direct decorations, the third one, the number of stories, etc. You notice these vectors are not saying coordinate X 45 by Y 500 is blue, right? These vectors are actual information that map to the metadata of whatever that object is. Now, once this information is vectorized, it's possible to compare these vectors. right? And in this example, we can see that these two vectors in the top left are more similar than the image that we have just looked at, the one that's on the bottom right. And we could have an image of a colonial style house or a skyscraper, and it would appear somewhere completely different to what we see here. But once we've vectorized this information, it's possible to not just see similarity between these different images. As human beings, we can see that those two are on the top left are similar, but because we're now storing this as a vector, we can use some out-of-the-box math to determine similarity between these vectors. And Oracle provides for you out-of-the-box Euclidean, dot product, Euclidean squared, Manhattan, cosine similarity, Hamming, multiple similarity search protocols that you can use to determine the similarity between different vectors. And we have some live labs that can step you through determining how these different mathematical distance equations work and how they compare to one another based on the problem you're trying to solve. And I strongly recommend you take a look at those live labs. Obviously, we have live labs that go much deeper than that too. But to get back to having this information, right, and this is the subtle difference that having vectorized information that it makes for comparing information, right? So when you think of a vector storing information about, we'll use words in this particular example, we could have some words such as fruit, right? Where we've got pears, apples, raspberries, animals, elephants, cats, puppies, and states, New York, Texas, and California. Well, when we use a similarity search operation, it's possible to determine correlation between the terms, right? So in a traditional relational model, we would look for an exact match. So we would look for where word is like elephant, if it's upper, lower, whatever, uppercase, lowercase, or where word in particular set of words, right? And keep that in mind. The other thing that we would also think is it would be fairly obvious to say, hey, if I'm going to pass a piece of fruit, if I'm going to pass the word banana, that would be localized and it would be correlated to this grouping of words. Likewise, if I put the word North Carolina, right, I would expect to see that near states. Where semantic search, semantic similarity, I should say, becomes extremely powerful is if I was to enter the word meow, it would land somewhere in this area of animals because there's a correlation between the word meow and a cat. I could also ask for the top 4 words associated with the word cat. And from that, I would definitely expect to see cat as number 1. And number 2 and 3 would probably be a toss-up between lion and kitten. And then number 4 would either be puppy or dog. And the reason being that many of these large language models are taken from information that's been trained from information that's available on the internet. And there may be places where these words are correlated, right? Cats and dogs in a blog article or a news article or something else. So this is what semantic search allows you to do, or similarity search, I should say, allows you to do. And I just got a database, a laptop upgrade just come up on my computer. So hopefully you're not seeing that. So what Oracle is doing with AI vector search to bring it back to how we're addressing this, the first thing we're doing is we've added a new vector data type for storing vectors. And this sounds like a cop-out, right? When I first heard that we were supporting a vector database within the Oracle database engine, I thought we were introducing this whole new cube or set of data that we would store information in. But what we're doing is actually way more intelligent. So we've introduced this column that's a new vector data type for storing these vectors. In addition to storing these vectors as a column in your data, we've also introduced a series or some extensions to the SQL language and syntax to allow you both to vectorize or embed your data, as well as to perform these similarity search operations. And then the final piece is we've added some indexes to accelerate use of using these vectors. So to show you the benefit of how we're addressing this, in this example, going back to the photo of the house, we store a vector of what that photo looks like. And we don't store the photo itself. We simply just store that vector, that representation with the dimensions of that picture. Once we've done that, it's possible to query from our table for houses for sale based on a vector that we provide. And basically, we're performing a similarity search. In this case, we're not saying which algorithm we're going to use. So the default will be a cosine similarity, and we'll find a house that looks similar to this one. Now, while that might be a nice feature to be able to say, hey, I'm looking for pictures that look like a picture that I'm presenting, from a business standpoint, it's not that valuable, right? It's no good if the house it's showing me is based in Tokyo, or if the house is well and truly above the budget that I have looking for houses for sale. So by applying this as a column that sits alongside your other relational information, we're giving you the power of being able to combine both your own relational queries and filter out information that's not relative to the search that you're performing. So by doing this, we're reducing the footprint of the data that we care about and really allowing you to run that more expensive operation on a smaller subset of data. Now you'll notice here, and by the way, you don't need this approx here. We've got this here to tell you that would be telling it to call an index, and then target accuracy of 95%. These are optional. You don't need to use these clauses at all. There are a number of embedding models we support. I'm going to skip past that. We support different types of indexes. We have, for in-memory style indexes, we have hierarchical, navigable, small world indexes. And for disk-based indexes, or where your data may be too large to be loaded into memory, we have IVF flat indexes. Now, I will point out, in some cases, vector databases that are available from other vendors follow the model of storing those vectors as a form of graph, right? An index structure. Oracle's able to blend or give you the best of both worlds. We can provide that graph mechanism, if you wish, by using these HNSW indexes or these IVF flat indexes. Plus, we give you the ability of storing that data as a relational table, as a column within a relational table. So one way that I'm seeing many people use vectors today, and this is taken from a customer out of New York that I've worked with, they've taken a ton of their documents, and they've taken these documents that are PDFs, about 2,000 of them or so. They're in the financial services space, and they have a lot of regulatory compliance and business rules that they have to follow. And they want an easy way to be able to query and to train their employees when they're looking up information. So they've taken these documents. I believe there's either 200 or 2,000 of these PDF documents. They've used the Oracle package DBMS Vector util to text to convert these PDF documents to text. Once they've broken them to or converted them to text, they've then used the DBMS Vector util to chunk. So they've broken these documents into smaller pieces. They've then embedded them to vectors. And then once it's vectorized, they're able to index it if it makes sense. And then their end users are able to come along and ask a question, and that question gets converted to the same embedding model, so vectorized, then compared or similarity searched in their database, and it's then retrieved out their questions are answered using that similarity search. And to look at it in a different way, they're taking their documents, in their case PDFs, they're extracting the information, breaking that into chunks or smaller usable pieces, which they're then embedding. And then once they're embedded, they're stored within the Oracle Vector Store. The user comes along, they ask a question that gets embedded, it gets similarity searched against the database. And in their case, what they're doing is they're then passing that information back out of the database, and they're passing it back to an LLM. And that information is being enriched by the LLM and being converted to a conversational dialect that matches their business, right? They're in the financial space. And that way they're able to address finding this information, mapping it to their business needs, and then also providing that conversational output. Now, that whole extra piece of that conversational output is really the RAG component that I talked about earlier, which is where They're taking their information, they're searching for it, and when it's being passed to the Gen AI engine, the large language model, it's being trained or being prompted, if you wish, to understand their specific business information as it gets passed over the fence back to the end user. Now, I've talked to a couple of customers who are doing similar things, and in this particular financial institution's case, they want the privacy of running with their data within a private large language model. So they're running with Oracle's OCI Gen AI service. I've talked to another financial institution, and they're working with a third-party large language model that's sitting in the public domain, and they're using LangChain for this piece. So LangChain is an API, and they're able to use LangChain to apply obfuscation of the information that's being passed over the fence. So because they're in the financial sector, there's PCIe and personal identifiable information rules that they have to oblige by, and this is ensuring that they're able to do that. Now, a couple of things that don't seem very obvious is that the Oracle database, by providing vectors as a column within the database, you're able to take advantage of all these other features and functions that are available to you out of the box with the Oracle database. Now, a couple of things I didn't mention that I should right now is that vector databases and the vector data type and everything is available to you today with 23AI without any additional installation necessary and without any additional licensing or pricing or anything else, whether you're using standard edition, whether you're using enterprise edition, Exadata, a Docker container, or an autonomous database, it's there for you and you can take advantage of it. Now, if you are running on an Exadata, guess what? You've got storage indexes, you've got Smart Scan, you've got Flash Cache at your disposal to accelerate those vector operations. And by the way, our latest Exadata software also includes an AI Smart Scan capability for accelerating those workloads. Now, one customer I spoke to is using another vector database engine for solving some of their problems, and they're looking at moving to Oracle. And one of the core reasons they're looking at doing this, if I go back to this image here, this one, they have 3 different categories of users. And to help simplify it, I'll use DBA terminology, right? They've got an HR user, they have a developer, and they have a sales user. So these 3 different communities of users are coming in to query their vector database. And in running their questions and doing their similarity search in their vector database, there's no isolation or delineation or separation of duties, if you wish, of what these users coming into their vector database are able to see. So in their case, what they had to do prior to working with Oracle was they had to set up 3 exact clones of their vector store and put in ways of masking the information that only set users could see. So when HR ran a query, they couldn't see sales information. When sales run a query, they can't see information that's specific to the HR users. Now, all of you would be well and truly aware that Oracle has fine-grained access control. We have privilege ways of controlling roles and privileges within the database that would just implicitly provide that support for you. So they're able to do that straightforward without any additional work to perform that operation. So I'm going to switch gears now and jump to some demos. Can you see my screen okay?
Before you begin, Sean, there's people are bursting at the seams with some Q&A. So I wonder if it's a good time for a break.
Yeah, for sure. So let me see the Q&A. Any plans to, oh, yes, definitely. Oh, so Anil, that question is about our OCI Gen AI service. And that's not our AI vector database capability, which is built into our database. So yes, in answer to that one, we do have plans to extend it, but I don't know what our plans are. And it's definitely something that I'm not privy to because I'm not within the OCI engineering team. And I see Roger's asked a question. Roger, how are you? So we have some Gen AI capabilities, but to experience all the Gen AI, customers need to go to OCI. Roger, that's a great question. So Yes and no. So in terms of what you're looking at using for Gen AI, you definitely would need to use a large language model, and that would be, or an embedding model to perform those operations. Now, what we're doing within the Oracle database is we have Onyx support, and with Onyx support, we're able to extend or bridge the gap between those Gen AI models that would be sitting outside the database, but we're able to compile them and run them from within the database. So it's a bit of both. Now, yes, if you're looking at using things such as chatbots or using conversational operations outside of the database, then yes, you would want to use some of those other Gen AI capabilities that we have within our OCI. And someone said, not yet, it's not available on-prem. So it is available on-prem in our engineered systems, right? So if you're using our Exadata or our ODA, 23 AI with our vector search capabilities is available on-prem in that footprint. It's also available on-prem with our developer free release. So if you're looking at using that, you can have access to play with it. Now, I'll also point out, if any of you have a specific workload that you're in a hurry to experiment with and to use, we can you can reach out to me, and I can work with you about getting you into our beta program. And rest assured, it's beta program in terms of it's a limited availability, and the way of applying a limited availability is to use our beta program to manage the legal aspect of getting you on board and having everything set up for you. But it is the production ready software that you would be using. So if you have a specific business need, that's one way of overcoming that obstacle. And then Roger's also asked me another question. It's sometimes hard to tease out what Gen AI capabilities are in the database versus cloud. Is Select AI only an autonomous database? Yes, correct. As of today, Select AI is only available in the autonomous database. Correct. And David, how does meow? Oh, so David, great question. So the whole correlation of that word, I'll show you that in my demo. So if I don't answer that, let me know, chime in, and I'll make sure to go back and recircle that. And I would want New York to be similar to New Jersey, not to New Mexico. Great question. So John, the way that that's done is with something called ranking or re-ranking. So in essence, what you're doing, so remember, your large language model and your results that you're retrieving from the database or from the large language model are only as valuable as the number of data points that it has to go off of. So you're going to see in my example, in fact, let me show you. I have a table that has 150 entries in it. And therefore, if I'm looking for information related to states, I have entries here. I have information about New York, Florida, Georgia, Colorado. I may not have New Mexico in here. So the chances are of coming up with New Mexico are very slim, right? In fact, it probably won't come up with New Mexico. So at the end of the day, the correlation is based on, and this is talking about vector databases, is based upon what information is in your data set, right? And by re-ranking, if I say, hey, I only care about the top 3 entries, and I asked about the boroughs of New York, I would expect to not see Buffalo and not see, I don't know what another entry would be for the boroughs, but actually, and I'm stealing that from a live lab that we have that I would recommend you try out, and I'll show you the QR codes for that at the end of my session. And someone else asked, is vector data gets sent to the LLM, and if so, how can we be? Okay, so that's a great question, and I think I believe I answered that. You can use LangChain, or you can use our OCI Gen AI service. Yes, I'll definitely share the slides with the group after this. Golden Gate is fully supported, and Golden Gate can also be used, and it has a pivotal role to play with respect to bridging data between different data sets. We have customers who are deploying workloads where they're using Golden Gate to keep those separate engines in sync. I'm not sure about limitations if that's relating to Golden Gate. I don't know the answer to that one, and that might be something if you want to follow up with us, Alexander. I'd be happy to get you in touch with one of our Golden Gate experts, or even better, set up an event for them to come and speak. Nick Wagner's a chap that I've been working with on that front from Oracle. You mentioned that one customer is considering moving to Oracle for AI capabilities. Oh, it's not just one customer. I'm talking to a minimum of 8 customers a week. I'm delivering sessions to. I'm working with customers who are using Gen AI, vector databases, you name it, from the financial sector to the retail sector, a very large convenience store chain. I'm working with airline companies. I'm working with government contractors. I'm working with a Hollywood movie company for post-production searches and stuff. I'm working with a website company, design company. The list goes on. So there are many, many customers who are using Oracle for their AI capabilities. Some of them are in the exploratory phase. Some of them are rolling their stuff out. And I'm not sure, is it about the supported LLMs, for example, or others? What may be the differences between AI and Oracle? Oh, so the core difference, I believe, for our vector database capabilities is that we're able to, it goes back to our Oracle Converge story, we're able to bridge the gap between your data and the various tools we have at your disposal to take advantage of vectors. So I can store my information in my database about my business transactions. I can also use the machine learning algorithms to perform fraud analysis. I can use vector databases to perform some form of similarity search. I could use property graphs to visualize fraudulent transactions. I could use JSON documents to provide flex fields and provide that level of storing information. So there's a whole bunch of reasons why we have customers going this route, down this path. And someone says they've installed 23AI on their Oracle VM desktop. Yes, if you've got 23AI on your desktop, yes, it's available there today. Just make sure it's running 23.4 and up. Obviously, the later versions will have more functionality. And XSCC in on-prem data center. Yes, XSCC for on-prem or in your data center will support 23AI. So let me show you a quick demo. And if there's more questions, I'm happy to get to them, but I think a demo's worth 1,000 words. So here I've created a table called My Data. I've got some columns in it. I have 150 entries of just random factoids. It's just a regular table. It has one column called ID, which you can see here's the ID. I have a factoid that I've called info, which is just a varchar2, and I've got this information in there. And then I've got V. This could be called anything. I've just called it V for simplicity, which I'm storing my vectors in. Now, I've defined my vector as wildcard, comma wildcard, or asterisk, asterisk, because I want the flexibility of controlling what I put, of not being confined to what I store there. This first placeholder is the number of dimensions, and this is the data type. So it could be 385 dimensions, and the data type could be float 64. And if you do that, it's going to give you much better footprint of storing the data and better subtle performance improvement on performing vector similarity searches. However, in doing that, my demo would be more rigid and I couldn't play around with different large language models. So I'm using wildcards, which is totally acceptable. So I've got that information there. Now I'm going to jump to this window and do a Python 3.11. I'm going to vectorize those entries in my database. And I'm using, and in this case, I'm using multilingual E5 large. So I'm using an open source sentence transformer from Hugging Face. And the embedding model I'm using is a multilingual one. And the reason for that is it will make more sense when I show you my demonstration. So I'm loading my data in there and I'm vectorizing my information. So if I say select star from my data where ID equals 610, which is this entry, Laura Decker is the youngest person to solo navigate the world. It hasn't yet vectorized. There we go. My 150 entries have been vectorized. This is what it now looks like. So that's the vector for Laura Decker is the youngest person to solo circumnavigate the world. Now that's also the vector using this embedding model, interfloat multilingual E5 large. Now that I've vectorized my information, I can do a Python 3.11 I'm going to run a similarity search using the same embedding model, right? I have to use the same embedding model for my similarity search. So in doing that, I can now ask it a question. And this is my re-ranking, right? Someone asked about New Mexico versus New York. So in this case, I can say, all right, I want to look for anything related to cars. And doing a similarity search against this information in my database, I have these entries here. This is all I have relating to cars, right? Ferraris are often red, Teslas are electric, etc. When I type the word cars, it understands using sentence transformers model that these are 5 entries that have come out that are the closest. And remember that picture cluster, right? They're the closest words associated with my factoid, associated with the word cars. Now, you'll note I said I use multilingual, and the reason I did that is look at this. The word car in French is voiture. I get similar results, not the same. Now, this could be that perhaps Ford F-150s are not too well known in France or wherever this large language model was trained in French, right? So it can be influenced by the different terms. I can do caro, right? Italian or Portuguese for car. And yeah, it's pulled up different entries once again. But notice it's got horses have 4 legs. I don't know what that correlation is. Maybe there is a racehorse named Caro or something, you know, who knows what it could be. And I don't speak Italian, so there could be another connection. Now, I'm going to try this one. I've used it with other sentence transformer models. I've not done it with multi-language. Yeah, in this case, the multi-language is coming up with hits that are pretty much a good hit, right? Wellington is the capital of New Zealand. Kiwis are birds. Sydney's in Australia. Kiwis taste good. There are no snakes in New Zealand. So 4 of the 5 are direct hits. This 5th one could argue is not really related to New Zealand. However, it is geographically close. It's probably the closest data point I would have in terms of location to the word New Zealand, right? Although, no, I do have the America's Cup entry in there, and that should have been pulled up. So there's different things you can do there. I could re-vectorize my data using a different embedding model. But let me show you what my script looks like to vectorize the data. I'm logging in. And by the way, this code is available for you if you do the live lab. You'll see this code is there and you can run this. What we're doing is we're going ahead, we're querying our table, and then we're updating our table to store a vector based on what our string of info is, right? So we query the table, we connect as our Oracle, we're using our Oracle database connect string to get into the database. We're then connecting into our large language model. If we were using Cohere or OpenAI or something that has a token to authenticate, you would see our authentication token being passed. And then we're looping through for every row, we're converting that info or the V column to store the vectorization of that info column, right? That's all we're doing there. And if you look at our similarity search, it's very similar. We're doing yet the same thing again, but this time we're taking the string that you're entering. In my case, I entered the word cars, and we're using that to do the similarity search against my data. I'm looping through my table, looking for I'm performing a similarity search, I should say, based on the information that I vectorized to do that comparison. Now, speaking of cars, I actually do have a demo that I filmed. I would show you the live demo, but I don't think I have enough time, and I want to make sure I get to all my demos for you. I just got to find a window with it. Oh gosh, where is it? I have too many windows here. Let me pull up. Oh, it might be here, or nope, it's not there. Bear with me. And this one is where I actually have the ability to, let me put in test4.py. Oops, my window has too many things in front of it. 23 AI demos. And I apologize, I'm planning to do this live, but sometimes it's better just to go ahead and show you the video. And if someone does want to see it live, if they want to set up something, privately, I'm more than happy to set up a Zoom to show you this code at work. But here I recorded it only because it takes about 5 minutes to run. I'm running out of time quickly. But what I'm doing here, let me jump really quickly to my presentation to explain what I'm doing here. I'm taking an image, and to get that image, I'm passing a URL to a public domain website that has images that you can use for websites, etc. I grab that image, I vectorize it into, using an embedding model, I vectorize it. I then generate a description of that image based on that vector. And then based on that description, I vectorize that description and then do a similarity search in my database to query those same entries that I have. So in my example, the one I'm going to choose is actually a car-based one. So I'm going to take a picture of this car. I'm grabbing this picture from this URL. I'm generating the vector of that image. I'm loading it, generating the vector. And by the way, this takes about 4 or 5 minutes. If we have time, I can show you one where you can choose what image you want to load up. I then generate the description of it, and I'm querying my same set of data using the picture, just as we did with that house. So you can perform these very powerful operations using that. Now, another demo I was hoping to show you or just show you the syntax of it at least, is the select AI, because I know this is something that a lot of you are interested in. And for what I'm doing here, in this case, I'll just explain what I have. I created my database. And by the way, select AI is supported in any flavor of the autonomous database, whether you're running 19C or 23 AI, right? So keep that in mind. So I'm going in, I'm creating, first of all, I'm going into my autonomous database and I'm allowing myself to get access to OpenAI through this port. I'm also granting access to DBMS Cloud AI to my admin user, which you'll get an error if you run this. It will say, hey, you can't grant this to yourself. But the point is that this is already granted for this admin user. But if you were going to create a different user, you would have to do that. Once I've done that, I then go ahead and pass my credentials to authenticate to my OpenAI or aka ChatGPT large language model. And then that's kind of like the setup. Once I've done that, I then go in and I grab some information about a table that I have. I have a table called sailboats, and I add comments on it. So this is the hack. This is like the cheaters version of building a solution using Select AI. I'm using the 101 version, which I'm just providing comments. So I'm saying, hey, my table sailboats contains information about sailboats, etc. And here are the columns. And this could be sailboats.col1, col2, col3. It's this that the large language model is looking at, right? It's associating LOA as the overall length of the boat in feet. So once I provide those comments, I then pass that to my large language model, right? And I could have any number of tables. I could pass an entire schema. I'm just passing admin sailboats and my credential to authenticate. Then I go in and I set my profile, which I'll copy that because I can show you that on VS Code right now. See if I'm still connected. Connection was terminated. I thought that might happen. I'll go ahead and set that. So I've now connected that. And I can do a sail. And when I query that, you'll see I've got entries of different types of sailboats in there, etc. Now I can say select AI. Here, what's a sample question I have? I'll grab a bunch of them. And I'm using VS Code right now, by the way. I'm not using the autonomous database to show these examples. But here I can ask, what's the average price for a lagoon? That's definitely not the SQL language there. Average price. What year were most fountain Peugeot manufactured? And that's based on information in my table, right? So keep in mind, I'm just querying my own table. This is not information taken from the internet. I'm using the large language model here to be able to interpret my statement and pass the result back. So it's a very powerful way of solving that problem. I don't have an example of RAG that I could show you, but if that's something you're interested in seeing firsthand, we do have a set of live labs that you can go to, and I've got the QR codes. The basics one, which helps you determine based on visualization and a plot of a graph plot. You can try out different similarity search algorithms to see the difference between, say, Manhattan, Hamming, or cosine similarity. And then we have these labs. This one will go through the exact example I showed you where I enter the word car and it pulled up Ford F-150 is very popular, for example. And then we have one for RAG. So the process I would follow would be to jump to this one to begin with, understand similarity search through the Oracle database and the different SQL packages we have. And then try playing with outside embedding models. We use Python. We have it for other languages, JDBC, JavaScript, Onyx. And then we allow you to use different embedding models. You could use Oracle's OCI Gen AI. You could use sentence transformers from Hugging Face. You can use ChatGPT's or OpenAI, any number of these embedding models to experiment with. So I definitely recommend you take a look at those. And hopefully, if any of you are going to Oracle's Cloud World, it would be wonderful to meet up, and I could show you some of these demos live. And then someone asked, Alexander asked, where can we download the vectorized code? Oh, that's star.py. So that vectorized code, I can share it with you. If you go to our GitHub repo, you can probably find it. If not, ping me. I'm more than happy to share it with you. But more importantly, if you just go to this live lab, the code is there. Just cut and paste and use it to your heart's content. As I say, we have support for more than just the examples I showed you. The stated goal as well is to provide the same mechanism that I showed you of doing my similarity search using my vectorizing through Python, but allow you to do that through the Oracle database. So any other questions? Is there something that I missed out that I should have answered that I didn't get to? Is there anything that's not clear? I kind of ran out of time, so I'm trying to make sure I address everyone's questions.
I think you got everybody. I see that the Q&A is at 15, and I think everybody is absorbing all the material that you've presented, Sean.
Wonderful. And here's my contact information, Coleman. If anyone wants to get a hold of me, feel free to email me if you want pointers to any of this or you want those lab links. And Coleman, who should I share my slide deck with? Should I pass it to you or Alina? Or
Yeah, both of us will be fine, Sean. We'll
I'll
post
do
it
that.
on our respective websites. It'll be up on Viscosity website as well as NYOUG.org.
Yep. And thank you both for Viscosity and
marketing email or to Coleman. Yeah, it doesn't matter. And then we will share. We will upload it at Orapub, your slide deck.
perfect. Thank you so much.
Thank you so much. It was really exciting and high engagement today from our audience. Yeah, so I just remind that this session is recorded and you can rewatch it anytime and download a slide deck at orapub.com, and we will send you the email out once it's downloaded. Thank you so much, and hope you guys register for the upcoming events we mentioned, and see you all next time. Take care.
Thank you, Alina. Hey, thanks, Kai.
Okay, I will end this session.
Thank you, Alina. End the session.
Thank you. Thank you.